Okay, so welcome to a proper flip lesson. So you'll be doing this video, you can stop it, rewind it, take your notes at your own pace. So we're looking at the binomial theorem, we're going to connect it with what we've been doing as well. So binomial is an expansion involving two terms in a bracket to some power. So what we've got is just a general thing, a plus b, okay, a plus b to some power. Okay. That's the start, so copy that down, and when you're ready, come to the next slide. So, if you had to expand a plus b to the 0, or a plus b to the power of 1, or a plus b to the power of 2, can you write out those expansions, and when you're ready, come back and see what I've got. Okay, so a plus b to the power of 1 is just a plus b to the 0 is 1, because anything to the 0 is 1. A plus b to the power of 1 is just a plus b. And the last one that you should be able to do is a squared plus 2ab plus b squared. That's one of the shortcuts. If you couldn't do it that way, you would have had to expand out the brackets twice, but eventually you'll get that. So what happens, excuse me, what happens when we have a plus b cubed? Now, just in pretending that you didn't get shown this last year, a plus b cubed is a plus b to the power of 1 times a plus b to the power of 2. So what I want you to do is, if you can't do that with a shortcut from last year, then just multiply those out. I'll just give you the first line using the answer above. So what I want you to do is just use the FOIL method, just expand out each of the numbers in the first bracket by the second, and then simplify. Okay, stop the tape, and when you're ready, come back live. Okay, so you would have got that, change colour, that, and then that. So that a cubed plus 2a squared b plus ab squared. And then underneath we've got, I'm going to line them up underneath so they line up with like terms. Plus 1a squared b plus 2ab squared, and then the final term is just b cubed, and that equals so you should have got that. Okay, it's just expanding out a bit slower, but you would have got that answer. Okay, so when you're ready, come to the next slide. So what we're doing is we're looking for a pattern in the coefficients as well as a pattern in the terms. And so far, we've got the first one was a 1, the next one was 1, 1, 1, 2, 1, 1, 3, 3, 1. So we're just looking at the numbers, the coefficients. So what comes next? Okay, so stop it, talk to a friend, see if you can work out what's the next line, and then come back live. Okay, so it starts with a 1, ends with a 1, and hopefully you would have seen 2 plus 1 is 3, 2 plus 1 is 3, so this next number is 4, 6, 4, 1. Okay, that's the pattern. Let's look at the next slide. So what is the pattern in the terms? So we've got a plus b cubed, so we're looking at the pattern in the terms now, not the pattern in the coefficients. Okay, so we had this expansion that we did a couple of slides ago. Okay, so the pattern is there's 3 A's, then there's 2 A's, then there's 1 A, then there's no A's. And for the B's, there's no B's, there's 1 B, there's 2 B's, there's 3 B's. So what would be the sequence for a plus b to the power of 4? So let's look at this line here to get the coefficients. So what would be the sequence? So it's 1, 4, 6, 4, 1, and then change colour. We have 4 A's, 3 A's, 2 A's, 1 A, no A's, and no b's, 1b, 2b's, 3b's, 4b's, and because the question had a plus, we can just put pluses all the way through it. When we have minuses, we'll fix it up. And so that's what the expansion is. Okay, so the coefficients at the moment come from the triangle, and then the terms just come from the patterns. And you should notice that at the moment, the numbers at the top always add up to 4 for power 4 at the moment. Okay, so when you're ready, copy that down and come to the next slide. So what happens when a and b are more complex? 2x minus 3 to the power 4. So what we do is we just do the same thing again. 1, 4, 6, 4, 1. And this time, that's a. So we have 4 of them, 3 of them, 2 of them, 1 of them, none, and then no A's, this is B, so no B's, 1B, 2B's, 3B's, 4B's, and just put pluses in again, and the minus signs will take care of themselves in a sec. So 2 to the power 4 is 16, 2 to the power 4 is 16 times 1 is 16, x to the 4. Now this minus sign will come through, so we've got 2 cubed is 8, 8 fours are 32, 32 times 3 is 96, it'll be minus 96, x3. Numbers get a bit big, so we've got a minus squared, so it'll be a plus. So we've got 2 squared is 4, 3 squared is 9, so we've got 6 fours are 24. We'll just stop the tape, I did not get the calculator, so 6 fours are 24, 24 times 9 is 216, and it'll be x squared. Okay, so we've got a minus cube, so a minus. So we've got 3 times 3 is 9, 9, 3 is 27, 4 2s are 8. That's 216 again. With the power x, and then the last number will be positive, and then we'll just be. So if you notice, with the minus sign, it goes plus, minus, plus, minus, plus. It just alternates. Okay. So copy that down, you'll get plenty of practice on those ones. When you're ready, come to the next slide. So what's the connection between the coefficients of the expansion and combinations, which is what we've been studying? Okay? So if you look at the fifth line of Pascal's, which is to the power of 4, the numbers are 1, 4, 6, 4, 1. And on your calculator, if you do 4C0, 4C1, 4C2, 4C3, 4C4, you'll find that you get those coefficients. And we can use that to take shortcuts so we don't have to write out the triangle all the time. So looking at the next slide. So using this, we don't have to keep writing out Pascal's triangle. So if you want to get the 6th power, which is the 7th line, coefficients, 6C0, etc., etc., etc. And can you just fill in those last ones with your calculator? Okay, so you would have got 15, 20, and 15. So there's a pattern. Once you get to the middle, it just repeats coming back. So that would be the 7th line or the 6th power of Pascal's triangle. Okay. So we come up with this general theorem. Okay, so anything plus anything, it doesn't matter if it's a minus because that'll fix itself up to any power. So the first coefficient is that power to the power of 0 to give us the first term. And then we just, the n doesn't change, and we just add 1, add another 1, add another 1, and we just keep adding until we get to the last one, which would be just n, c, n. So the numbers match up, like 7c7. And then with the letters, we start with the first letter to the highest power, and then we just take the same letter and subtract 1, take the same letter and subtract 1, take the same letter, subtract 1. And with the B, the second letter, there's no B, and there's 1, and there's 2, and there's 3, and you just keep going. Like over here, this will be, the last term will have no A's, and it will just be B to the power of n. So the easiest way to do it, if you look at the patterns, the number underneath matches the number of the second. The number underneath matches the number on the second. The number underneath matches the number on the second. And how do we get the first number? You just subtract. So n minus 0 is n minus 1, n minus 1, n minus 2, n minus 2, etc. So can you copy that down? And come over. So, using the general theorem, we don't have to do all the hard work, we can just use it. So, if I want the third term of a power 7, okay, because the third term won't have a 3 because the first term starts with a 0, like it's 7c0. So the third term will have 1 less. So that's A, that's B. So we have A, subtract those two numbers, we get 5, and then we put the B, and that number just matches. So that number matches, and then just do the mathematics. Okay, so x to the power 5 is x to the power 5, 2 to the power 5 is 32, 3 squared is 9, 7c2 is 21, so the number at the front is 6,048 according to my calculator, so you can check that and see what you get. Okay, so copy that and move on. So here's a harder one. Find the coefficient of x5 in the expansion of blah 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 to the power of 7. Now, if we just find, okay, just have a look and then I'll make it a little bit easier. So if you just put k there, then we have to subtract 1 because, like we did on the previous slide, if we want the third term, we subtracted 1. So if you subtract 1, you get k minus 1, and then you get all these messy k minus 1s. So rather than having k minus 1, if we just change, if we just change that k to k plus 1, see what happens. Too far. So by changing this to k plus 1, now we've got nice numbers here, here, and here. Okay, so have a look. So 7ck is some number we don't know, but the indice laws, you multiply, and then this 2 over x is 2x minus 1, but 2 to the k is 2 to the k, and then x to the minus 1 times k, that's minus k, make sure it's clear. And then the indice laws, I've got some x's here, and I've got some x's here, and I'm multiplying, so I add them, I get that number. So for the question said, what is the coefficient of x to the 5? Then the only x's are here, so that means that that power must equal 5. So k equals 3. Okay, so k equals 3. K equals 3, that means I've got the fourth term, and then just plug it in and get the coefficient. So again, you'll get plenty of practice on those. And there's an exercise that we'll be doing. This will be about at least two or three lessons worth. Okay, so I hope you've enjoyed. You can obviously rewind and watch any parts. Bye.